Hello everybody and welcome back. Today we'll go ahead and continue with our querying system. Today we'll go ahead and implement this query object. And off camera I was thinking about how to better do this, and I think the best thing we can do is to actually go the other way around. So having a query object by itself, defined by itself, and the universe to use that query object to query the storage and give us access to the items. So without further ado, let's go in that direction. We'll start by changing the tests. So instead of creating the query using the universe, we'll have a query. So we'll have a query, and it will be default construct. It will be default constructible. Now we will register the component. And another thing that I was thinking about off camera was how to know which kind of access to the component we want. How to know if we want read-only access, mutable access, or that kind of access where the component might or might not be there. So at least for the read-only versus mutable access to the components, my idea is to register a component with the query using with component to get read-only access, and for mutable access to use with component. So this is for read-only access. Yeah, so we have that, the query. Now the universe will run the query, and we pass the query, the run query method. Okay, so let's copy this and update the other test. This one is for mutable access. So for this one, we'll go with component mute. Perfect. Next. No, not there, but down below. This is the case for read-only optional. In this case, I'm not quite sure. I think with try component, something like that. And instead of get, do try, okay, try get. I'm not sure, but let's go with the flow in this direction, and we'll see what we end up with in the end. But this one is for for mutable option. Okie dokie. So query with try component mutable. And next, oh, I'll need to remove those sets from all the tests and build a separate test, but we'll get there in a minute. I think there is something wrong with this test, so try component mutable, and we do try get mutable, and we want to have, yes, this is what we want. Try get perfect. Okay, and let me start the Pomodoro timer. It's something that I want to try. Maybe it will help me work more concentrated on the subject at hand. Okay, so now let's go and implement default for the query object. We have query, we no longer need the universe. We'll need something else, but we'll see in a minute what. We can rip that out and do implement trait default for query, paste, and this one is default, comma default. Yeah, whatever. You don't like the way I want to do things. Okay, I have no idea what's going on. Okay, now it's fine. So let's get rid of the lifetime here too. Perfect. And by the way, you see at first when I created this with component method for the query, I was thinking to check the existence of the component at the query creation, but I think I'll better do it at the moment we want to run the query. So this will not return a result, but self. Okay. And we also need those with component mutable, with or with try component, something like that. I don't remember the names. So this is for the mutable case, and with try component. With try component, this one I'll go with optional. Yeah, when we build a query, we'll use with optional component, but then from the query result, we'll do a try get. So let's go like this. Okay, let's go like this. Okay, so we have a few problems, and let's deal with them step by step. So in the universe, I have to not get rid of this, but transform it in run query with mutable reference to self. Okay, and with the return type of result vector of query items. Yeah, query item. And for the error case, query error code. And just tag it as to do. Nice. Next. Here, what's wrong here? What's wrong with the query here? Oh, yes. So, yeah. Import that. Actually, okay. Universal query. This function takes zero argument. Well, not because we need a query here. Okay. And the things we need to take care of are those things for the optionals. What am I doing? Here with optional component, read only a mutable. Okay, that's done. I need to define try get and try get mute for query item. Query item for this one. So we have get mute. And do we need result or just an optional would be enough? Let's go with results, and if we figure out that we don't need results, we'll remove that. So this is try get, and we get result with a reference to an option T, and for try get mute, we have a mutable reference to an option T. Perfect. Now, what's wrong here? Here we try to... yes. So because the try get will give us an option, a reference to an option, we actually don't need to wrap that in option. Instead, we just want to mention what we try to get from the result. Okay. So remember that I mentioned I want to add a test for the case when the running of the query fails because the components we are looking for are not there in the PCS storage. The test what the no, query error unknown component. And for this one, mutable universe, a query with component usize with component mute. Now there's a thing we should not be able to have something like with component usize and with component mute or with optional component or with optional component mute of the same type. So what I will do, create this test and then create another one to make sure that we don't register the same type with different access criteria. So with component mute F32 with optional component. What should it be? It should be signed integer and just for kicks, let's have a struct dummy here and with optional component mat of type dummy. Okay, then I'll do let result equal universe.run query. We give our query and we get our results, and here we assert the fact that we got an error of type unknown component. So assert equal result to no, just result, and we expect it to be error of what type? Query error. This one that will rename to unknown component, and we want to get some metadata about what components are not known. So here we will have some metadata of type vec. Now the thing is, this might be, well, I'll keep this order: read-only, mutable, optional read-only, and optional mutable. So a vector of strings, and I expect them to be what? To be your size, then what? Use size f32 I32 and dummy, I hope. Uh, of course, this will fail because we need to have here a vector of query item, not query item, but query component. Query component. No, just strings, sorry. So here we have just strings. Or the assets I want to get rid of. I wanted but forgot. Okay. For non-components. If I run, not like that, like this. So if we go like this, something is not implemented, line 37, this one with component. Because of this, let's implement those. So to be able to know if we want mutable access, read-only access, optional read-only and or optional mutable, we'll have to keep track of the things we register. So I'll go components, and this will be a hash map of something. Query access type, query access. Let's go with query access type, and we'll rename it if we find a better name. And we map those query access type to type IDs, a vector of type IDs. Okay, we import hash map, and we have to define this. And this will be an enum. Public enum query access type, and we have read, write, try read, and try write. Perfect. And let's do hash map default, and to register stuff. So for with component we go, first of all I need all of those to be mutable. I guess for all of them the basic command is the same. So self dot components dot insert, and we have the key, and we'll skip that, and then we'll have type ID of of the generic parameter t, semicolon, and we return self. So in this case, we have query access type read. In this case, write. Whoops, write. And in this case, try read. Okay, yeah. So in this case will be try write. In this run method, we no longer need this for the query object because the universe will run the query. But what's wrong with this insect? So it's complaining about the fact that query access type is not implementing hash eq. Okay, so derive debug partial eq hash. Oh, come on, hash eq. Perfect. And now what to? Oh yes, we need to bound this to static. Miss expected struct vector of type ID. Oh yes, indeed. Indeed, we have a hash map of vectors. So bear with me. Bear with me. It's a bit more complicated, but not something we can't do. Self dot. First of all, let me reset the timer. Self dot components dot get. We try to do a get mute of this. Try insert. Oh, try insert. So tries to insert a key value pair and returns a mutable reference to the value in the entry. Let's see an example. So we have the hash map. We do a try insert of 37A. Okay, I see. But I don't want to do it like that. I don't think it's even working. Try component has nope. Contains. Yes, so we check if we have not the type ID, go back. Check if we have a vector for the read-only components. So if we don't have that, we do the insert, else we just do self dot get not components dot get mute of query access read and safety. Okay, safety. At this moment, we know for sure we have something. We have something. We have something. So we have a vector there. So we just unwrap it. And what's going on? Okay, we need to borrow that. What about here? And here we insect a vector of this thing. And what else? What else is wrong here? So we have back. Ah, yes. So semicolon there, and this is going to push the type ID, and we compute it above type ID. So let's type ID equals that. Now let's take this one and use it for the others. Or should I create a helper function? Just create a helper function. So extract this. Extract into function. And we want to pass in actually just this if statement. We extract this into a function based on the type ID and the access type. So in this case will be a query access type of type read. Okay, perfect. So let's change this and also add the access type, query access type. paste there, paste here also. Let's rename this to register component. Register component. Let's move it down. Copy those two lines. Actually, no, just do like this. We copied just that line and we do a paste, paste again, and paste again. Okay, perfect. So we are done with the query construction and components registrations with the query. And we no longer have errors. We have some cleanup to do. And let's test our test. Okay, the test is failing because something in universe. So in universe line 350. So this one. So the first step is done, creating the query object. Now we want to run the query, and we do this in two sub stages. First, we check that the components we are interested in are available. If not, we return an error. And if they are available, we go ahead and return some accessors to the components. So this will do this like so. First of all, for each access type in query dot components, but actually for each access type and component in query components. Okay, let's define this getter. We have our query and we have a public at create level and we do public function components components, and we have this this hash map. Okay. Good. So we have we iterate over this hash map, and now what do we want to do? We want to have let mute has errors. So initially we have no errors. In case we have errors, we want to collect the names of the component types. So those strings we will collect here. So we want to build this vector. So we'll have a mutable unknown components, a vector. Good. So inside this for loop we'll do this. So we have our access type. We have our access type. And for now, I think I can ignore the access type. But with the components, I'll do this for component in components. Well, query components. And this is a query component. What do we do here? We check, we do an f self.buckets keys. No, has key. Contains key. And the key is the component, the query component. So if we have that, everything is fine. The problem is if we don't have it, then we want to fill up this unknown components vector with something. So we'll push something. And you see, we can't push query component. Well, we can, but for a user, it will be meaningless. The user will go with like, what the heck is this 64-bit type ID? Instead, I want this query component to have two fields, type ID and type name. Type name. So let's go. The query components are coming from query components, and we have a hash map of query access type, and we are mapping to a vector of type ID. No, we want to map to a vector of query component. Yep, that's exactly what we want. So let's define this query component. So public at create level struct query component, and we'll have a public type name, no, type ID, and a public type name or string. Okay, now let's fix this. So here we'll have a query component. Why are you not visible? So query component. Yeah, I don't know. So, okay, so we have type ID and type name. We get this from std any type name, and we pass in a generic parameter t. So in this case, let's do like this. Static. Then this type ID goes away, and we'll compute it inside. We'll compute it inside here. So let's type ID equals that. Query component. And we can do even better. Let's query go away. Component equals that, and we pass in query component there and query component there. And we delete that, and we add the generic parameter here. That should do it. Yes, that's doing it. Okay, perfect. Okay, let's do the cleanup. Now back to the universe. So here we have query component, and we go and grab the type ID from inside. Yeah, so if we don't have that key, we push the error, and we also mark the has errors flag true. Now else. What do we want to do? Not else, but else if. If we are not in the error state. So else if has errors is not true, what do we then? Then we do a match based on the access type. We do a match on the access type. What what did I do? Okay, I have no idea what I've done. So with this, query access type public. Why is it not visible? The component bucket query item. Let's put it manually there. Okay, now it's fine. Now, based on the access type, based on the access type, what should we do? Okay, now we have the access type. We know for sure the component is there. So if it is read-only, we go to the buckets and we get the bucket as read-only for the type for query component type ID. Okay, we borrow that. So we get that. And it might be there or not. So this get gives us an optional read-only reference. So we have a can I wrap this? Let's reason a little bit. So we check the key and then because this we know for sure the bucket is there. So let's do the so for sure we know the bucket is there. If we get a crash, we better get it and fix the issue. This is the bucket. But we need another for loop. We need another for loop, an outer for loop to go over those columns. So let's do that. So we have for entity ID and record in self.entity ID records. For that, first of all, we jump over the records that are vacant. Occupied, and we have an index and the component bits. I think we can ignore that. Oh, come on, go away. Record. Okay, nice. Okay, so back to our bucket. We get the bucket. We have no idea for, well, we know for which type ID, but we can't downcast it. So we need a way from a component bucket. So component bucket, but from a component bucket, I want to expose also those get and get mutable. Optional reference to D. Yes. By default, this is the implementation of component bucket. Okay, so we have self.get. Wait a minute. Okay, let's define them in the function get self optional reference to snap. I think I can parameterize it to t there and get mute an optional mutable reference and oh, I need to check the documentation for downcast. Yeah, in a minute. And this is T, so this part is covered. So get what's the API for this one? I don't get it. Oh, those are defined by me. Yeah. Those are defined by me. Oh, let's go and check the documentation. So Rust vector get. Do we have get? We have get. And we have this beautiful signature. Okay, let's steal this. Okay, what am I doing? Yeah, I'm stealing that and putting it there. Okay, slice index, whatever. Go away. No. That and mutable option. Okay, mutable slice index t. I think that's all. Get mute. Slice index output optional mute. Okay, let's check it out. Optional mute here. Okay, so we have get. Okay, let's raster downcast create generic parameter downcast. So this one is for we just go like that. Nice. Perfect. So what's wrong with you? The trait defined with one generic parameter and bucket, and we just defeated the purpose of the component bucket. So this is not good. We should not have this here. If we don't have that there, let's put it here. T, perfect. This one is no longer needed. This goes away too. Then what's wrong? The trait, so the trait component bucket cannot be made into an object. Oh. Yeah, we need to think of a better way. So let's scrap that. Let's scrap that. Okay. I think I'll downcast it to a vector of any. Let's see if if that works. So downcast to any. Tweet object must include K. Expected result cannot be invoked on trait objects. Okay, that's fair. Instead of going downcast, what we can do here? Okay, I have the storage and I want this location. I'm on the column at the moment and I need to pinpoint the cell in the matrix or the cell in the bucket. And somehow I need to do this with the component bucket trait. But without let's try something. So if I do function get and we get a read-only reference to self and we return an optional reference t, we might be able to do self dot get. No, because self here is a component bucket, is not a vector of t. As ref as what? Try. So I can access length index of vector get. Come on, really? Vector of type t. This is weird. So I have this one. Is this implemented in a trait? So methods from the ref target. Really weird. Well, it's not weird, but it's weird for me. And how are we implemented? Index.getSelf. Okay. Huh. Let's try it out. Okay, function get that. Um, where are you? The function get is not a member of trait. Ah, okay, fair enough. So let's define you in here. Cannot be so for a trait to be object safe, it needs to allow building a vtable. So why component bucket? Ah, okay. Okay. So let's try the other way. Let's try implement the ref for component bucket. Let's index output. And those are methods from the ref target slice t. Target slice t component bucket. For okay, dynamic this. Okay, default and static. So what do you propose? Okay, so I think I'm at the end of the third Pomodoro. If I'm at the end of the fourth, I'm looking here, so I recorded for around 1 hour and 15 minutes. I linked it up here, so the takeaway is this one. We converted the query in something more like a data transfer object. We implemented halfway the run query. So now if I run this test for the query error component unknown, we don't get it to pass because we have this here. So let's comment that so we have it in mind. Let's kill those and shiny. Let's comment this and just mark it as to do, and also here to do. Okay. Do mute. Yes. Clone. Okay, this one fails, but why not implementing? What's not implement? 387. 387. Oh, this one. Okay, so yes. We will rather do if it does not have errors, we mark it as to do, else we return error of what? Query error, unknown component, and we pause the list of unknown components. Okay, so this is not passing because again something is not implemented. 388, 388. Really? Come on. Yes. You see the problem? Because we don't have any occupied column, we just keep this check. So the way to actually do it would be to move this for block and this if block here. Running test, not yet implemented. We still go there? Oh, come on. Okay, actually here. Yeah, that's it. Well, so we get an error unknown component And okay, use size, F32, F32, I32, I32, and dummy. Oh, but this one gets the full name. So basically I have to split after double colon and get the last piece of the puzzle. Okay, let's do that. Let's do that in here. So we registered the component and we compute the type name and we split ter split. Oh, come on, how do I split it? Split. Rest split string. Split yada use split. What? I don't get it. So I have the string. Actually, I don't want that. I want to split it in halving. I don't know. So type name gives us a string slice. Why I can't choose you? Split collect. What am I doing wrong? Split based on that. So expected struct. Okay. So the language server is going nuts again. So let's restart it. So I split. And then I want to get the last. Oh, perfect. Last. And I unwrap it. And I clone it. Well, not clone it, but yeah, you get it, the idea. And now we pass the test. So coming back to what we did, we built the query. We check if the storage contains the elements. What's left to do is to actually run the query and construct a vector of where are they? Query no component of query items. So we'll do that tomorrow. Bye bye. Until next time.